take a little while there. So we're looking at a couple of quantities. The first quantity that we're going to look at is something called pressure. All right, so let's take a look at the pencil. You want to try to figure out the two quantities, right? Nathan already back. Right? We want to try to figure out the two quantities that will determine pressure. All right. So the topic that we're doing is hydrostatics. And our first subtopic that we're going to focus on is something called pressure. All right. So if I were to take a pencil, right? If I were to take a pencil and I were to apply a force to the top of the pencil, right? On your finger. Okay, not so we'll be using the point and we're using the eraser. Right? Tell me which one hurts more. Yeah, you apply a force here, turn it around, and you apply a force here. Right? Which one will hurt more? The point here part or the part with the eraser? Point here, right? So what do you think? What do you think changed between the point and the eraser? The sharpness, which is what? Due to what? Area, right? So therefore, pressure is dependent on area. Of course, if I would have just leave it like that without applying a force, I wouldn't feel anything. So pressure is dependent on two things: force and area. Right? If I were to increase the force, would the pressure become larger? Yes. So it means that force and pressure directly related. You all remember those words? Directly related, right? So pressure is directly related to force. What about area? What about pressure and area? Which area is smaller? Here or here? Bottom, right? So if I apply the same force with the smaller area and with the larger area, the pressure is larger for the smaller area, right? So what's the word gears use? How they related? This one is directly. This one is what? Inversely. You all remember how to write it? Proportional to 1 over. That's okay? So remember this? For those who never saw this before, right? Whenever you're writing something and you have the concept of inversely related, you write it like this. P is proportional to 1 over the quantity. The directly means as one increase, the next will also increase. Right? As one increases, the next will also increase. So that's directly related. What we need to learn to do, of course, is to combine them. So if I combine two of them, I'll get pressure proportional to, just multiply them, and you'll get force over area. All right. So if I want to determine the pressure on a solid, the pressure on a solid is pressure is equal to force over area. And it should make sense, right? If I give you a large force, pressure will be large. If I give you a small area, pressure is large. That's okay? Of course, we have to know our SI unit, right? What is one of the units for this? Most people know the derived unit pascals, right? But pascals also has other units. Anybody can tell me one? Force is normally in what? Newtons. And area is in meters squared. So we divided them, right? And if you don't want to write divided, what you could write? The minus sign it. That's okay? So this is Newton per meter squared. That's okay? We need one more. We need one more SI unit of pressure. What will that be? We had to break down Newtons, right? What is Newtons made up of? Force is what? Mass by acceleration, right? So Newton is force, right? Which is mass multiplied by acceleration. Mass is in what? Kilograms. Acceleration is in meters per second. and then you multiply it by area. Sorry, you divide it by area. Sorry about that. And then this will simplify to kg. This is 1, same base, add the powers, 1 plus minus 2, minus 1. All right. So these are the three SI units that you can write pressure in. These here, this one here is called a derived unit. Right? This one here is a piece unit. Right? Because we have base quantities only. Okay with that? So in a question, they can ask for the base unit pressure. Yeah. All right. Copy this down. I'm going to give you a small note on pressure. Right. For those who never saw the words, write them down, right? So you know what directly means and inversely means. You go in the back of the class and you ask him what's that. So you can come and sit down here and you will see everything. You can come and sit down right here and you will see everything. Every single thing you'll see. Well, if it's not for you, you tell her. Right, take a small note. Pressure on a solid. Pressure on a solid. Right, pressure on a solid is dependent on the force. Pressure on a solid is dependent on the force exerted by an object force exerted by an object and exerted by an object and the contact area and the contact area of the object on the surface and the contact area of the object on the surface. It is important to note that the smaller the contact area, it is important to note that the smaller the contact area, it is important to note that the smaller the contact area, the greater is the pressure exerted, the greater is the pressure exerted on the force, sorry, on a surface, on a surface, on a surface by constant force. On a surface by constant force. Online, you're getting through? If I call to pass them, all right? Serena, are you okay? Yeah. You're okay with that? So you would recognize that once the force constant and the area is small, you have a lot of pressure. So here we have two examples. We have a dull nail and a sharp nail. Which one do you expect to have a greater pressure? First one or second one? Here, right? And the main reason is that the area here is smaller. Okay? So simply all we have to write here is this one is, you can say, small pressure. And of course, here is your larger pressure. And all we had to do was simply allow the surface area to be smaller. Right? So if you're applying a force to a nail and trying to get into a piece of wood and not entering, all you have to do is find a way to make the area smaller. Okay? Let's take a look at a knife. All right? If we have a knife has two sides, right? Which side of the knife is sharper, Alex? Side A or side B? Why? Why? Just talk about it. What there? Why? Right? So the pressure on side be larger, but why? Tell them. So it means that the pressure is because the because the surface area is small. I want to hear the word area, right? So yes. So side B has a greater pressure because the surface area on side B is smaller, right? Side A, right? Applies a smaller pressure, right? Because the surface area is larger. Okay, so two small examples just to show you how area basically controls pressure. All right, try your best, enjoy it. And then I just write from which side has the larger pressure and why, right? Side A or side B has the larger pressure and why. After you enjoy. Right, just remember to write y side d as the gradient pressure, right? Because of the surface area on that side of the knife. Right, and I want to give you a scenario and you tell me how to solve it. Some of you all may have seen the solution already, but I want to tell me why. Right, I'll give you a scenario with this. Ready? So scenario C. I wanted it somehow to solve it, right? During a snowstorm, during a snowstorm, yeah, right as well. During a snowstorm, so we're trying to get a solution to this, right? During a snowstorm, Nathan wants to walk through the snow from point A to point B. It don't matter how long, right? He wants to walk through this, snow from point A to point B without continuously sinking in the snow. Without continuously sinking in the snow. What's up? Help Nathan. Help Nathan. What he can do. Right? Help Nathan. See if we can figure out what Nathan could probably do so that he can walk. Let's say let's short distance, here to the wall. Right? What Nathan could do so that he doesn't constantly keep sinking in the snow. Because if you're walking and you keep sinking in the snow, you gotta keep taking your foot out. But what he can do? He can do whatever he wants, but you run into the same problem. Right? But you have to figure out how we could solve that problem. Some of you may have seen it already. But let's try to figure it. Of course, the reason I asked that the solution has to do with this. All right. Think about it. If you don't want to write it, think about it, and then I'll pick on somebody. For pick later. I'll pick later. Alright? I'll pick on backward too. Right, so we need some ideas based on what we have, based on what you see in there. Right? Walk in the snow, so you gotta figure it out. How are we solving this problem, Nathan? It's all the problem there. Keep it. Yeah, Nathan, help out. Nathan, hurry up, please. No mouth. Hurry up. What I did plan, you know, it's not about. Yes, sir. Yeah, I'm right, so how you can do that? So you need a bigger surface area, right? So the pressure that you apply to the snow will be smaller. How you can do that? Make snowshoes. Yeah, basically. Right? Anybody anything else? Anything, Samir? No guess? Ethan? It'll be the same force, but because you have a large surface area, right? You make the pressure applied to the snow smaller. So remember, every time you walk on the snow, you're applying a pressure, right? If you walk with your shoes, right, your surface area is a little bit smaller. But if you get a snowshoe, so I just give you an example, right? Your shoe might be this size, and a snowshoe might be this size. So by increasing the area, remember it's the same force. Who applying the force? You, right? You are applying the force, right? So if you have a larger surface area, then the pressure will be smaller. Make sense, Ethan? You sure? Anybody else put something different? Nothing? Ethan, something different? All right, online, anybody has something different? All right, anything different, Jared? You're okay with that? All right, so let's write this down. To solve the problem, Nathan can. To solve this problem, Nathan can design snowshoes. Guys, and so it is. Take his word and very good. Next one. Mango is wide. I forget what I'll say. To solve the problem, Nathan can design shoes that have a larger surface area. That have a larger surface area. And hence would apply a smaller pressure on the snow. And hence would apply a smaller pressure on the snow. Allowing him to easily move from point A to B. Right, so we want to do some small calculations, but before we do that, let's do a little bit of maths. So pressure is force on area. Tell me what is force now. Tell me what is area. Right? So pressure is force on area. Tell me what is force. Tell me what is area. And come see if you remember how to complete this triangle. Try that part. So make force subject of the formula. Make area the subject of the formula. And if you can't make triangle, don't worry, I'll show you what to do. Right? But make force subject of the formula. Online message your answer for force, please. Everybody. Right? Everybody online message your answer for force. You make force subject of the formula, right? And Jan, Arista, and Gerard. Chill, I think just in chill. Oh yeah. Make force subject of the formula, then make area the subject of the formula. We can complete the triangle to right side. All right, nice learn stuff. Okay. So first thing you need to remember that pressure is technically over one, we can cross multiply. So you'll get one by force, which is force. Pressure by area is that. So that's the first formula. Force is equal to pressure by area. From right here, you want to make area the subject. So you can just divide both sides by P. So you'll get force on P is area. That's okay? Right? Again, if you struggle with this, you could just use the triangle. The triangle tells you the same thing here. Force, which is on top, is pressure by area. So for example, if I ask you to find pressure, just block out P and you will get force on area. If I ask you to find force, block out force, and you will get pressure by area. If I ask you to find area, block out area, and you'll get pressure. Force and pressure. Right? But you should be able to make this subject at the formula, right? All right, let's do some small calculations on this. Some small calculations, right? A person of mass 50 kilogram. A person of mass 50 kilogram. Right? A person with mass 50 kilograms. Is walking with a shoe of surface area. Is walking with a shoe. Both shoes put together, right? Both shoes put together. A surface area of 0.05 meters squared. Find the pressure exerted by the person. Find the pressure exerted by the person. Take a time, take a minute, find pressure. Find the pressure exerted by the person. Let me see what you're going to do before. What did I give you there? Mass or force? Mass, right? So what's the force exerted by that mass? The object what? Think about it. If I give you an object, right? And this object applying a force, downward force. That's what? The object weight. So you have to take the mass of the object and find its weight. Okay? Use gravity as 10, right? Use gravity as 10. Just to make sure you're doing the first one right. Pressure is equal to force on area. The force of the object is the mass of the object by gravity all over the area. We know what the mass is. Is it correct SI units? Kilograms, right? Remember this, right? Kg meters per second, right? So that's to be in kg. The gravity is 10. And acceleration is, area is 0.05. Right? You can probably give me the standard form. For y'all guys. Put in standard form. 1 by what? What will you get? 5,000. 10,000. So just put 10,000 Pascal. Okay? Right? 10,000 Pascal. Do the same thing here. Do the same thing here. You get lost? Where you get lost? You have mass multiplied by gravity. That's the force. And then divided by area. Right, book the pressure here, and well, of course, one bigger than the next, right? One bigger than the next. So I just want to know why it's similar. Why one bigger than the next? Oh, wait, now let's check. So I'm just Google. If you don't hear your name, I'll give it a little less than the other team, right? Gerard was online. Nice. Gerard, Serena, Fantina, Angelita, Taylor, Nerissa, Shabby, Vicky, Keaton, Ramcharan. Yours is Keaton. Aliyah, Selena. Marianne. The marriage, I don't have your laugh. Still in. Still in what's near part one. Which is still in what's near part one. Still the same Monday. Right. Good. I'm Richie. Right. Next Richie. Switching. It's cool. Right, what we got here? This is 50 by 10 all over 0.001. So you got what? 5 by 10 to the power of 5. Which one is larger? And the main reason why is what? smaller surface area, right? So the main reason why this is smaller, this is bigger is because the surface area is smaller. That's okay? Yeah? All right, nice. Let us continue. Number 3, one more example. Right, let's say I gave you a block, right? And the mass of the block is 100 grams. And the pressure exerted by the block is 10 pascals. I would like you to just find the force. Part 1, find the force exerted by the block. And part 2, find the mass of the block. Right? So I've given you the pressure this time. The pressure exerted by this block is 10. The mass of the block is 100 grams. I would like you to find the force exerted by the block, use the right formula, and then find the mass of the block. Take your time, use the right formula for force, and then find the mass. Wait, what did I ask the mass? Sorry. Only I make a mistake here. And then you can summary mistake. Yeah, it's good area. Sorry. Find the force exerted by the block and then find the area. Sorry. Online, remember these small answers, you can message, right? Right? So sorry, find the force exerted by this object and then find the area of the object. Mass is equal to small things like that, right? Right, so first thing I recognize is the mass is 0.1. So therefore the force exerted will be M by G, always write your formula, substitution answer, right? Substitution will be 0.1 by 10 is equal to 1 Newton, right? Don't magically go from here to here, right? Just show them, right? Show them that 100 grams is so much kilograms and how you can with force, right? If you don't want to write this, that's okay. But this part here important. Formula, substitution, answer. That's the way they give you marks, right? That's okay, you found something shorter. And then find the area first. Right, so the answer area is what again? Force over pressure. So we know the force is 1 Newton, pressure is 10 pascals. So the area is 0.1 meters squared. That's okay? Easy, right? Okay. So today so far we've been dealing with pressure on a solid. Right, Ethan? You want to change it now to see what happens in a liquid. All right. Let's look at this little simulation here. Online, any question with it? Any problem with these questions so far? Narisa, good job. Serena, nice. Didn't get any answers from Ania. Hold on. Anaya again, sure. And Petro, you look nice Monday. You want to give trouble there already. Anya, sorry again, sure. Sorry. But finally, yeah. Huh? The run of the run the pipe down there. The run of the pipe from outside. The run of the pipe. Instead of pipe on that side. I think some big friends on the outside one outside. I don't know what how you close up this school for a little while.
So I think Alex really friends.
Who?
Alex, really friends.
All right, let's see. Hold on, yeah. I want to show you simulations here on pressure in a liquid. Right, let me see if we get it. PHEP. No. This one, no, not this one. Hold on, yeah. Where is physics? Now this one did work for. I have physics classroom on the tablet. I don't know, that's not kind of liquid, fluid pressure. That's not how. No, yeah, that's the physics classroom coming up. All right, let me see if this can work. Hold on, yeah. This is sort of it. It's one with a container. It's one with a container and 3 holes in the container, but sometimes they redirect people to different things and then they just start charging. All right, let me see here. position of bottle A, B, C. We saw the water coming out. Tap the water there. And things change in there, Alice. Huh? Yeah, but how you putting water in bottle? But it don't move higher, hold on that. Right, so I'm putting pool at the bottom here, putting pool a little bit higher here, right? I'm gonna just drop this one down a little bit. Put the water on a move it. Watch the water in there. Look at the bottle. I'm holding on the water thing. Position of pool, top middle, bottom. Remove T, but I'm putting water in there. We have nothing inside. We want to see how the water will behave as we have three different holes, right? Are we? Okay. Oh. Nice. Put in. Oh, now we can put it. Now we can put it. Yeah, you better put it on. All right, good. Nice. Nice. Just happen. What do you want? All right, nice. So basically, the deposit should have been of the same depth, but let's see what will happen now. Right? What you might recognize there, I'm not sure if you'll see it in fact, you might recognize that the water, where the hole is the highest, the water squirting out the smallest distance. You're seeing that? And where the hole is the lowest, that's all the way down here. Stop. The stream of water. Anyway, what's supposed to happen here? In this case, I could do it, right? Right? The higher the hole is, right? The higher the hole is, the closer the water will here to be here, and here the water will squirt down the furthest. Right? So the lower the hole is, the further the water will squirt out. Right? And there's a reason for that. Do you all ever jump into a pool and recognize it lower, or even in the sea, and you try to go down to the sea bed? You find a squid here or hurt your nose something? Right. Because the lower you go, the pressure is what? Greater. Right? The pressure, the lower you go, the pressure is the greater the pressure is. So for example, here, if the hole was quite up here, then the water will squirt out like that. If it's full in the middle, the water will squirt out like this. The normal simulation is one container. All right. So what this shows is that the lower we go, the greater the pressure in the water. So that means that pressure in a liquid is dependent on what? Depth. Right? So you see like our pressure in a solid was dependent on area. Pressure in a liquid is dependent on depth. All right. And what do you think will happen? What do you think will happen? I kind of want to go back and do it with this simulation. But if I made the hole at the same point, what do you think will happen? So if I made the hole at the same depth, what do you think will happen? It will be the same pressure. So it means that the water will go down the same. Are you okay with that? Yeah. So at the same horizontal depth, pressure is the same. At different depth, pressure will vary, right? Quick last question on this. Look at the shape of the particles. Why the shape didn't make a difference? Look at the shape. Right? If you look at above this hole, you have so much water. Above this hole, you have so much water. Above this hole, you have so much water. If you look at the last container, you might expect the pressure to be the largest, right? And because you have more water on top. But what that means is that pressure not really dependent on the mass of the water. What is dependent on is the density of the water. If I change the density of the water, the pressure will change. So for example, if you go Ethan, put this terminal, right? If you go the same depth in a pool as it would in the ocean, the pressure in the ocean will be larger, right? Because the density of salt water is higher than density of normal water. Okay, so pressure is dependent on density, is dependent on gravity, and is dependent on depth. The pressure in a liquid is given by rho g. You remember the symbol for density? The kind of funny looking P. Yeah. So these are the things that we're going to look at now, right? So head up pressure in a liquid. Pressure in a liquid. Right, although I'm making it right, remember all these things in the handout as well, right? If you missed anything, you can go back to the handout and I'll send it back when I add it to the group, right? Right, when I add it to the group, I'll have your I'll add it to the group, right? All right, so let's take a look at pressure in a liquid. All right, so we're taking a look at lasting pressure in a liquid. All right, so as I said, I like to give you this relationship first so you can see everything from it, right? Pressure in a liquid is dependent on density by gravity by depth in the liquid. Right? Symbol density. I have a little curl here too, right? Density by gravity by depth. Right? We know the SI unit is pascals. But what I want you to give me, I want you to give me, based on these quantities here, give me 2 SI units. It will end up being 1, yeah, but it will simplify it from, right? So you have to remember the SI unit for density, gravity, and height. See if you can remember that. See if you can remember the SI unit for density, for gravity, and depth. And let's see what you get. Okay? Write the formula and see if you can get an SI unit. So the SI unit for density. Don't forget the SI unit with density. Well, just now as examples of some you know. Right, so density is kg mass divided by volume. Right? Mass divided by volume. Gravity is what? ms, no, not the value, the SI unit. ms minus 2, and the depth is measured in meters. Simplify this, tell me what you get. That's multiplied, right? Top final dot here. Yeah. Huh? Somebody can say. We got that fast a minute, quick. She know she works so she wants to know all them songs on them. I so I laugh now. Oh. The recording back.
I don't know what I'm going to do that.
Yeah, what y'all got? Minus 3 plus 1 is what? Minus 1, right? So you're going to get kg m minus 1 s minus 2. What that looks like? And that is the same thing I gave you a little while ago. Check and see. Check and see for the base units for pressure. Same thing. Okay? So they both apply, so that means this formula, the word is called homogeneous. Why you gotta learn that for now. Right, underneath this, right? Pressure in a liquid is dependent on its density. S to the minus 2 here. S to the minus. Pressure in a liquid is dependent on its density. And depth. Dependent on its density and depth. Full stop. The lower we go in the liquid, the the greater is the pressure obtained. The lower we go in the liquid, the greater the pressure obtained. Right? And then you have two quick diagrams to draw me down. Okay? What would happen here again? Where would the water go? Closest, right? So the water will go the closest here. Here, medium in between. And here, it will go the furthest. Right? So the lower you go, the greater the depth. So if they ask you to draw a diagram to show it, it's a nice diagram that you can use. All right? What about if you have the holes at the same depth? What will happen? Right? The water will come out the same. Right? So the first one is for different depths. This one is the same horizontal. Yeah. Right? And the water will squirt out the same. Right, after you draw that, one thing I want you to do for homework from her, I want you to write a small note on the hydraulic lift. Alright, so we're gonna take a look at the hydraulic lift next day in the YouTube manometer. Right, and look at some past papers on this. Next class, I'll manage the group, I'll add you all to the group. There's a chance I might not be here. But if I'm not here, someone you put on. Right? Yes, next class. Message just confirm. I'll go back tomorrow. And copy it down, please, before every class, spend 5 minutes and go over this thing, right? So you'll do good in the Kahoot and you'll know where we left off last week. Yeah, I guess something. Well, I did copy this one. If you have score, if you just score at the end of the month, I'll give it a score. I'll add a four. Yeah, alright, online, that's in there, right? Enjoy your evening, you'll log out, right? I'll see you all next week, bye.